Hi, I'm Kevin Hess, and welcome to the Mouser Electronics Newest Products and Advanced Technologies online conference and trade show. Today we'll introduce you to what's next when it comes to new technologies and applications impacting the future of design. We have a tremendous lineup of industry experts and insiders sharing the latest trends, technical expertise, and product breakthroughs to stimulate the brain cells. With that said, let me introduce you to our keynote speaker, Kyle Wiens, CEO and co-founder of the popular gadget repair site, iFixit. What started out as providing teardown guides, tools, and replacement parts for Apple products has since branched out in all manners of gadgets and has become a clear voice for product design. Today he'll share his insight into Kinect sensor technology and how it's evolving from the gaming world into future areas of development. Welcome, Kyle.
Thanks, Kevin. It's great to be here. I'm honored to be a part of the first Mouser online conference. This is going to be a really exciting day, and I'm thrilled to kick it off. I'm here in San Luis Obispo, and I use this slide all over, but that's actually where I am right now, so that's pretty exciting. I'm in San Luis Obispo, California, and the weather is awesome, and I hope the weather is good where you're at. iFixit gets our hands on all the new gizmos when they come out, tears them apart, and we talk about what's inside, and that is one of the most exciting things to me, to see how other engineers get in and create and design hardware. It's really, really fun to be on the reverse engineering side and get exposure to so much hardware. iFixit sells parts for basically every Apple product made since '98. We sell parts for game consoles, Xboxes, and that's we're not trying to dominate the parts market. Instead, we're just trying to provide a service to the people who are on our site and need to be able to get in and fix their own hardware. More interesting to you is that we take apart all sorts of gadgets. So in this photo, we've got teardowns here of several of the new tablets, the Galaxy Tab, all the way back to, we took apart for fun last year, we took apart Apple's first tablet, the Newton. And that was really, really interesting to sort of get a blast from the past and see what was inside. So before we go into what I'm going to talk about today, which is this gadget, the Microsoft Kinect, I'm going to go through some of the teardowns we've done in the past and just show you some sort of cool photos inside, and also tell you a little bit about how our teardown process works, because it's kind of interesting. So the first thing we got to do before we can get in and take apart hardware is we got to get the hardware, and sometimes that's really a challenge. It's important for us to be first to make news headlines on Engadget, Gizmodo, and so we go wherever we have to go, and we wait in whatever sorts of lines we have to wait in. This is me in front of an Apple store, camped out waiting, and yeah, we're the guys in the front of the line that everybody thinks are crazy, but sometimes that's just the only way to get hardware first. We don't have special relationships with the OEMs. We don't get hardware early. We go and we buy it like everybody else. This is our lab here in San Luis Obispo. It's a little bit different than a traditional electronics lab, a lot more focused on disassembly tools. We take photos and we diagram, we show the inside. And we post all the photos on iFixit.com along with analysis. We have a team of mechanical, materials, electrical, and computer engineers working on staff, helping us as rapidly as possible dissect and analyze the internals of the devices. And when we do a teardown, we release it on iFixit as a wiki so that anyone can go in and help us learn via the process. But one thing that we're not always able to do is get the device in our lab, because we have to go wherever in the world the gizmo comes out first. And in the case of this phone, the iPhone 3G came out in 2008, and it was a big deal for Apple because it was their first 3G product. They wanted to launch that worldwide, and so they launched it in 20-something countries worldwide. And so we're looking at the map of all these countries and saying, well, which country is it going to come out on first? If it's July 11th everywhere in the world, where does July 11th happen first? And it turns out that's New Zealand. They're 20-something hours ahead of us on the West Coast, and so I hope there are some members of the audience from New Zealand. If so, speak up in the chat room now. We had to go to New Zealand to get the iPhone, and my partner Luke and I were once we realized this, we're sort of staring at each other and we're like, well, shucks, who has to go to New Zealand in the middle of July? That's really going to be a shame. And so we were kind of fighting over it a little bit because we both wanted to go, and finally we decided that we would settle it with a flip of a coin. Flip the coin, I lost, and so Luke got to New Zealand, and this is inside of the phone. You can see, just to prove that we actually went to New Zealand, this is the crazy New Zealand power adapter that you're not going to see anywhere else in the world. So we're trying to move the industry forward a little bit by sharing the information where teardowns had historically been proprietary. Every company does teardowns, they don't always talk about them. Well, why not? I mean, it's a fact. These devices are, you know, the Kinect that I'm about to take apart has a Marvell processor. There's no reason that should be a secret. Let's talk about that, and let's talk about why it's interesting that Marvell has that design win. So with that segue, let's take a look at the Kinect. If you're not familiar with this product, this thing is a phenomenal piece of engineering. The Kinect is not a standalone device. It's an accessory. It has a bunch of sensors packed into it, and I'm going to walk you through the sensors and talk a little bit about why the Kinect is revolutionary. This is just a little bit of information on what is inside the Nintendo Wii. The controller's got an accelerometer, and then the Motion Plus adds a gyroscope onto that. Plus, it's got an IR receiver. It's actually a very, very accurate IR receiver. I really like the Wiimote. It was revolutionary in its day. So Sony's current competitor to the Kinect is the Sony Move, and the Move is a camera that sits at the front of the room, and then you've got these controllers with a bulb on top and colored LED and then a gyro and an accelerometer inside. And so that allows them to do very fine control, actually even finer control. If you want to do a sword game, the PlayStation Move is probably better than something like the Kinect because it is more accurate. This is the reference implementation that the Kinect uses. The electronics inside are driven by a company called PrimeSense, which is a startup out of Israel. They have developed a custom processor that takes the input from the two cameras, processes it, and then sends a depth map out to the Kinect. So I'll go into a little bit more detail on how that works, but let's cut over to the video and I'm going to show you what's inside the Kinect and how to disassemble it.
Here we are with the Kinect. This is the first time you can control your console without actually having a controller in your hand, which is pretty exciting. It's made up of two cameras and an infrared projector. This first camera is just a basic VGA camera. The second camera is an infrared camera that picks up the light from the infrared projector. So that projects an invisible light onto you, and then the infrared camera picks it up to tell the device how far away from it you are. The Kinect is the result of hundreds of millions of dollars of research packed into one tiny device. So I'm going to open it up and see what's inside. So I'm ready to get started, and I've got all of my tools. I've got a tray for my screws, two spudgers, one metal and one plastic, a 5mm nut driver, a T10 security Torx, the 54-piece bit driver set, and my heat gun. You can also use a blow dryer. So to get things started, I'm going to remove the rubber pad off the base of the Kinect. So once you remove the rubber pad, you'll find 4 Phillips screws hidden underneath. I'm going to go ahead and remove those now. Once those screws are removed, this base just pops right off. Underneath the plastic base, you'll see 4 T6 Torx screws, so I'm going to go ahead and remove those now. When I remove the metal base, you'll see the motor and the gears inside, and this enables the Kinect to actually follow you around as you're moving. You can see the motor here. It rotates these gears, which rotates this gear, which enables the Kinect to tilt up and down. So that's it with the base. Let's move on to the body of the Kinect. I've already done this once, so it's going to seem a lot easier this time around. There's actually a great deal of adhesive underneath these grills, so when you do it, it's going to be a bit harder. But what we're going to do is take this metal spudger and just pry these grills off. Underneath the vents, the very first screws you'll see are 4 T10 security screws. It's kind of funny that those are the first ones we see because it's pretty clear that Microsoft doesn't want us tearing this apart, but that's not going to keep me from doing so. I've just removed 2 stickers because there are additional screws hidden underneath those. Once you've removed all of those security screws, the top of the Kinect should just come right off. Now we've got our first look inside of the Kinect. The first thing you'll see are 3 circuit boards here, here, and here, connectors for each of the cameras and for the infrared projector, a fan which is directing air this way, and then just a little fan cable there. Now that we're inside, the next step is to remove this fan and these 2 vents on the sides. You won't need any tools, just a little bit of finagling will get them out. Now we're going to disconnect the fan. Nothing really fancy about this fan, it's just an average fan. Now that we've removed the fan, we're going to take the bottom off the device. It's not going to feel good, but you're basically just going to pry it off. Now that we've removed the fan and the vents, we have a pretty good view of the heatsink. It's obvious that Microsoft took a lot of care in planning the airflow through the device. It's only 12 watts, and one wouldn't think a 12-watt device would generate that much heat, but maybe they're concerned because of the problems they've had with the Xbox in the past. The next thing we're going to do is remove this circuit board by taking out these T10 screws. I've removed all the screws, and now I'm going to use this spudger to disconnect this board. Now, you don't want to yank this completely off because there are lots of cables connected in here, so you'll want to be careful to disconnect those first. Now that we've got the boards removed, we're going to remove the heatsink. Now, for that, you're going to use your heat gun and a plastic spudger. I've already done this once, so it's going to be really easy. Yours will take a little bit longer. But once it's warmed up, it's fairly easy to pry off. The next thing we're going to do is remove these 4 standoffs, and for that you're going to need your 5mm nut driver. If you get to one that causes you problems, you can always take another screwdriver and put it inside this one and use that, because that tends to make it a little bit easier. While I'm here, I'm also going to get these ribbon cables. And now we can take the board off. With the boards removed, we have access to the screws holding on the front plate, so I'm going to go ahead and remove those. Now that I've got those screws out, I'm going to route these cables through this hole down here in the middle. Now that we've got the cover off, we get our first look at the Kinect's cameras. It's my favorite part. I think it's kind of cute. Now we're going to remove the cameras. Now that we've got the cameras out, it's completely disassembled, so let's take a look at what we've got. That's it. That's everything that's inside of the Kinect. Every time we take something apart, we like to give it a repairability score, that is how easy it would be for you to repair the device on your own. We gave the Kinect a 6 because it's relatively easy with some challenges. One of the good things about the Kinect is that it's very modular, so if you needed to replace one bit, you could do that, and I don't have to break out my soldering iron, which is always nice. The bad news is that it's pretty clear Microsoft doesn't want you getting into your Kinect because they used a ton of these T10 security screws to try to keep you out. Until you have the right screwdriver, it's really hard to get in. Also, without a repair manual, it's going to be pretty difficult to repair the device. However, once one's available on ifixit.com, we think you'd be able to get in there and repair it yourself. So that's our teardown. You can see more details at ifixit.com, and if you've got any questions, you can leave them in the comments below, and I'll come back to answer them for you.
So since we made that video, we've learned a little bit more about the Kinect, and there's been a lot more innovation that's come out. So let me walk through, again, just the PrimeSense a little bit more technically than what MJ did in the video, and then I'm actually going to show you how the Kinect works. So the PrimeSense reference platform is what I'm showing you here, and there's a lot of information on PrimeSense's site. PrimeSense is an interesting company. They are an Israeli startup. And what fascinates me about PrimeSense is that Microsoft has here one of the most significant R&D projects they've ever undergone. I mean, they've integrated voice recognition, a tremendous amount of kinematic motion. They've got a lot of optical engineering into this device. And then they're building it all on the reference platform of a third-party company. And knowing Microsoft like I know Microsoft, I would sort of expect them to have brought that technology in-house, and I'm surprised that they haven't bought PrimeSense. Now, I'm told there are a few reasons for this. One is, rumor has it Microsoft offered a lot of money to PrimeSense. I heard over $100 million to buy the technology. PrimeSense turned them down, which means that their CEO has a vision for the company being worth much more than that. I'll talk about that in a minute. The other reason is that I think that some of PrimeSense's funding may have come from Israeli defense contracting, and that there may be some legal entanglements. But I've just heard that through the grapevine. And I think it's sort of interesting to see Microsoft, for whatever reason, they have their cutting-edge platform. Yes, a lot of it is in software, but the hardware is really built around an open platform that anybody else could build a device around. And that's what PrimeSense is doing. I think they're a very exciting company, and I'm going to keep a very close eye on them going forward. I saw at CES this year they had worked with some other hardware vendors to create some other devices that were even smaller than the Kinect. It was about half the size because it didn't have the audio sensors, the directional microphones. There's 6 microphones along the bottom of this that provide direction and noise canceling, so that if you're watching a movie, you can still control the movie with your voice, which is something that is proprietary Microsoft technology. The PrimeSense technology is purely focused on motion recognition. This is a photo of the 3 sensors. What we've got here is on the left, you have a VGA camera. This is fairly standard VGA camera, although the optics are tuned specifically for where Microsoft is expecting it to be in the living room. The center sensor is the infrared camera, which only detects in the infrared. It's also VGA resolution, and it's interesting, at just 640 by 480. It turns out, I believe, that the reason that they went so low on the resolution is that, one, they're doing a lot of intense computation on it, on the Kinect itself, before they send it to the Xbox, and the other is that the Xbox is somewhat old hardware now, and they wanted to keep the CPU overhead of using the Kinect sensor's input to drive data to the game under 10 to 15% of the total CPU of the Xbox. And so they do offload as much of the processing onto the Kinect as they can. And the Kinect is actually it's sending the Xbox 2 video streams. One's a 640 by 480 standard video. The other is a 640 by 480 depth map. This is the pattern the Kinect projects onto the room. And if I had an IR filter on this camera, what you would be seeing as I point the Kinect around the room is it's transmitting a grid on the room. And then when you have objects in the way of that grid, the camera picks up that mesh and then interprets the distortions in the known field, turns that into a depth map. And you think about that, if you were to use a pure software CPU that's fairly computationally intensive, throwing custom silicon at this is the best way to get that, that sort of imagery, that sort of processing power. Throwing custom silicon, you can do it in a much lower power envelope. So that's interesting. Now, one thing that you notice about the Kinect, and I'm actually going to show you the insides of the Kinect here a moment. I have a disassembled Kinect that we used for that video I showed you, and this is inside. And cooling was really a consideration all the way through the Kinect. The entire system, what we've got here is long boards with a fan blowing across the board so you can actually get cooling, and they left enough space in between these 2 main boards to get cooling all the way through. We've also got a pretty serious heat sink here on the only part that, on the only silicon that produces a little bit of heat. And I'm going to remove that here. And then this here, this is the Marvell processor. The Kinect itself is relatively simple. We've got a lot of audio circuitry and the PrimeSense reference platform, but it really is just, we've got our two video sensors and the IR projector, and then this LED is just a status light. And then on the bottom, this is rotates up and down, and so the Kinect can look up and down and left and right and calibrate and hone in on where you are exactly. And some of the parts that we see on the board, let me walk you through all the parts that are on the boards here. You can see a little easier in this photo. So we've got a Wolfson audio stereo codec with the microphone preamp, Fairchild semiconductor MOSFET, an NEC USB hub. The Kinect's interface is USB, along with power augmentation because standard USB doesn't provide quite enough power. We have a mystery flash unit. I put the markings up there on the screen. If any of you know what it is, I would love to know because we actually haven't identified it yet. we think it might be an SPI flash made by Atmel, but we're not quite sure. Sometimes it's a little bit of a black art getting inside these things, and we don't have access to all the manufacturer data sheets. We've got the Marvell application processor. It's a system on chip which has a built-in camera interface controller. And then Hynix is making the SD-RAM, relatively small, just 512 megabits of RAM to drive just the system on chip on here. And then on the other side of that board, analog devices, op-amp, we've got a TI, AD converter, Allegro systems, stepper motor and DC motor controller, and that's kind of interesting. That's for the stepper motor that drives the Kinect going up and down, and that's it. The Kinect's motion is actually fairly precise. The entire Kinect system is designed to get the highest fidelity output out of these sensors, and so everything Microsoft can throw at this to get the sensor input accurate, they're going to. And so they've done that with really over-engineering the audio system, building a lot of cooling to make sure that they don't have any interference from higher temperatures coming in on the cameras, and then also doing surprisingly highly accurate motor controller to really let it fine-tune where it's at. And they're also using an accelerometer to counter vibrations. Actually, I didn't identify the accelerometer on this photo, but there's an accelerometer in here, and so then if they have vibrations on the floor, they can actually use that accelerometer and hardware to counteract the vibrations in the image. You can imagine, and I've had this happen, I've been playing the games and you're jumping up and down, and then the floor bouncing up and down actually knocked the Kinect off of my TV. So this is the layout of the Kinect, and I will be in the chat room. If you have any more hardware questions about the Kinect, please ask me, and as soon as I'm done here, I'll answer some of your questions. This is the audio sensing setup with the microphone cables going to the main Kinect. And now, so that's sort of the hardware. The hardware Kinect is interesting, but what's even more fascinating is what people are doing with the Kinect now that it's out there, and we've got basically a $150 three-dimensional sensor that provides a depth map over USB that's not encrypted. And so when the Kinect came out, Microsoft didn't say anything about whether people could hack it or whether it was an open interface or anything like that. And so some of my friends at Adafruit, another open source hardware company, issued a challenge, and we helped them out a little bit, and we said, hey, why don't you see if who's the first person to basically reverse engineer the protocol and make the information available. It turns out it wasn't encrypted, it was very easy to access, and now we've got all sorts of really interesting applications where people are taking the Kinect and doing all sorts of interesting things. And so I wanted to show a few examples, but first I've got software on my computer, and this Kinect is hooked up to my computer, and so I'm going to show you, and this is our camera setup in the room, so my camera guy didn't know that he was going to be on film here. But this, and I can interact with this, and we can actually see, as I move the Kinect around a little bit, you can see its view of the room is shifting. So what we've got here, let me go full screen. The colors that you're seeing are the distance. So the more purple the color is, the closer it is to me, and this light here is the closest to me. And the black is the shadow that's left. So if I look straight on, that's effectively the video image right there. But I can pivot around to the side and really get a 3D feel for the room. So given this, that all of a sudden I've got this very accurate representation of the depth of the room, what are some of the applications for that? What are the things that people are doing? And I'm going to show you, go back over to my presentation. And I've got a few videos of some interesting things that people are doing, some hackers, and I use hacker in the most pure engineering sense, that we're all trying to make the world better. We've got something existing that maybe wasn't designed for this, but I mean, the Kinect is a sensor, right? It's not a gaming accessory, it's a sensor. It's a 3D depth map. It gives you a real-time feed into what's in your physical environment to the computer, and this is the first time we've had that at the $150 price point. We've been able to get LiDAR sensors, the rotating, very fast laser rangefinders that the folks like doing the DARPA Grand Challenge have used, but those are in the $10,000 to $15,000 price range, and those haven't been available to typical grad students. So now we've got cheap sensing available to hackers everywhere, and they're doing all sorts of exciting things with it. So the first thing hackers do when they get a new gizmo is they make some sort of lightsaber demo with it. So I'm going to show you here. This guy has he's got computer vision recognizing the stick, and then he can control his lightsaber that way. It's pretty fun. And then here, what we've got here is these guys created a software overlay where they were able to, they have to connect in a known position, and then they go to the software and they say, all right, this area on the floor in this grid arrangement, those are keys. And I've got a virtual piano. So if you remember Tom Hanks in Big, and he's got the floor-sized piano, well, this is a virtual piano. And just take a look, it's really cool. Isn't that great? I just think it's so cool seeing some of the interesting, fun play that you can do. And I don't know why Microsoft doesn't have an application like that for the Xbox, but it's phenomenal to see the sort of innovation and off-key thinking. You put a platform out there and people develop for it. Now, what I would note is all of these applications that I'm showing you are people are making their own software interfaces. So Microsoft has released an SDK for the Kinect. But most of the exciting applications that I've seen haven't been using Microsoft's SDK. They've been using the Open Kinect project, and PrimeSense is sponsoring an open source platform for working with the sensors. So I think it's actually a little bit of a missed opportunity on Microsoft's part, waiting 6 months to release the SDK, because there's already so much momentum around these open source tools by the time Microsoft released their SDK. So this is an example of something that their SDK certainly doesn't support. The Kinect, as you saw in my demo, is fine, but it's not a truly 3D representation of the room, because anytime you have an object, it creates a shadow behind it, and you can't see behind the object. Well, if you have two Kinects, maybe you could get a much better field of view. So that's what this hacker has developed here. Let's take a look.
So my concern about interference was not as bad as I had thought. There is some interference for sure. If I turn off one of these images, you notice that there's a lot of black stuff that is not supposed to be there. If I turn off the other one, you can see it even worse. So this here, all these holes that you have here should normally be resolved. So that is definitely, and you can also see on the checkerboard here in the background, which by the way I used for calibration. So there's definitely some interference, but it's not as bad as I had feared. And especially if you turn both of them on, they pretty much fill in each other's holes. So it is not, it is actually quite usable. And as you can see here, because we now have two of them from about a 90-degree angle, I'm of course still not getting the entire object, because for that I would need to have another one in the back. But at least we get, well, we get 3/4 of the object. We have the top face, we have the left face, the right face, and the front face. So that's actually pretty good result, I have to say. The calibration is still a little bit rough around the edges. You can see here that the edge of that footstool is not exactly where it's supposed to be. But that's just a matter of getting better calibration done. So actually I'm quite optimistic right now.
So clearly he's still got a lot to do fine-tuning the multiple sensor approach. The image is a little bit jittery, but it gets the point across that the potential of this technology is phenomenal. You could, if you were working at the hardware level, you could fix the interference issues by projecting dots in different wavelengths, and then having multiple cameras that had different IR wavelength filters. And you could imagine placing Kinects throughout a room. So what if you had a room that had 5 of these PrimeSense IR projector filters, and you walk into the room and the room knows at all times where everything is? And that's PrimeSense's vision. That's why they didn't sell to Microsoft for $100 million. Because they see a vast opportunity for these sensors being ubiquitous everywhere. And if every room in your house had a couple of sensors and the master house controller knew where you were at all times, and you could walk into a room and it recognized your face and set the lights and the music to exactly what you wanted, we can get to seamless computing where the computers have enough data about the world and about you that they can really do a lot more intelligent decision making than we have now. So a lot of these sensors initially have been rolled out in mobile because that's where the hot development environment is at, but I see this being the vanguard of ubiquitous computing, where we're going to get very inexpensive sensors all over the place embedded in everything that we have. The next video I have here for you is, I absolutely love robots and I like flying things, and clearly I like the Kinect, and so this sort of merges all three together. The Kinect is lightweight enough that they're able to actually mount it on a quadcopter, and off of with the Kinect on the quadcopter, now you've got a complete autonomous flying platform that has a 3D sensor and can see its environment. And the LiDAR sensors that I talked about, those were too heavy to mount on a quadcopter. So we're seeing a tremendous amount of innovation around autonomous pathfinding with 3D sensing. If you're interested in this stuff at all, you see a video like that and the light bulb just goes off in your head. The possibilities for this technology are absolutely limitless. And we're going to see a lot more innovation, I think, coming very soon with very inexpensive flying platforms. We can have autonomous drones. This technology is best indoors where the sensor range, it is probably in the 10 to 20 foot range. But it's exciting, and I'm excited about even more inexpensive sensors coupling this with things like IR rangefinders and infrasonic sensors. We could really build very accurate, inexpensive sensing platforms. So let's take this back a little bit. I mean, fine, the Kinect is a very expensive engineering project, and it's probably not, all of us aren't going to be designing devices like this, but what sort of lessons can we take away from looking at the Kinect's design and looking at what hackers' responses have been to the Kinect? And it's not just hackers, by the way, it's all sorts of academicians. That last video was from Berkeley. So the first lesson I want to really drive home is that whether you like it or not, people are going to build on top of your technology. Whether you're making something as integrated as an iPhone or an Xbox peripheral, there is a world of curious engineers just like you that are going to want to take your stuff apart and do other things with it. And rather than fighting that, initially Microsoft's reaction to the Kinect was to say that they would prosecute people who hacked their Kinects and reverse engineered their technologies. And very quickly they backpedaled and realized that was a mistake. And you can't invent everything. You can't possibly imagine every way that people are going to use your technology. And so I think a really important engineering design pattern is to embrace what innovation people are doing on top of your technology and extend that and enable them. And Microsoft putting out their SDK is a clear example where they understand that the innovation around the Kinect is a very good thing for them long term, and they're embracing that. The same thing with Apple and the app ecosystem on the iPhone, right? Apple can't possibly imagine all the uses of this hardware, so they're making it available. And what's especially powerful with the iPhone is you've got so many sensors involved. You've got high-resolution cameras and GPS, accelerometer, gyroscope, magnetometer, all the sensors that are built into this. And even some things that people haven't even thought about, like the microphone input on the iPhone then enabled Square to do payments processing, where you wouldn't think that the iPhone would be a mobile payments processing platform. These cheap sensors, I think, really change everything. They change the ball game. And we're seeing that. I mean, now we've got accelerometers, magnetometers, gyros, basically in one package. If you can get that in a small package that's small enough to throw into any device, why shouldn't my SLR camera have a gyro built in and use that to do image stabilization? I haven't seen that yet in the Pro SLR space, but it sure seems like a huge opportunity. So my final point today is that ubiquitous sensing is the future. Getting these small, inexpensive sensors everywhere in our houses and in our homes, I think will really drive innovation going forward. We've been seeing companies like Intel looking for new applications for the ever-increasing processor power. Moore's law is relentless, and we're looking for applications to consume that CPU usage and really take advantage of modern compute capacity and cloud computing with compute capacity available in the cloud. I think that where we're going to see a lot of the data come from that we need to power those applications is ubiquitous sensing everywhere in the home. I think it changes everything if we have a home with sensors throughout where every device, every room completely understands everything that is going on at all times. And then you can layer all sorts of interesting software and applications on top of that. I would love to see an app store built on top of home applications. If you have a home with ubiquitous sensing, what sorts of millions of interesting applications would people come up with? I think that's really exciting. But what drives that at the core is the hardware. And that's why I'm really excited to have been given the opportunity to talk to you today. Thank you very much for your time. And I'm excited to see what else is coming up next at this Mouser conference. I think it's going to be a really exciting day, and we're going to see a lot of innovation. So thank you very much. And Kevin, back to you.